Welcome to another episode of Links Digital online series OpenCV with Python. So today we'll be looking at the other filters that OpenCV offers. So for example, the median blur, the Gaussian blur, bilateral filter, and why do we even use all these filters? What are the specific applications that they can be used on? Alright. So now let's look at other filters that OpenCV has too. Median blur. Let's just call it median blur. We do cv2.median blur, and then we pass in the image again to the grayscale frame and size of the kernel. So for this one, what we do is we pass in, it has to be an odd number, and we pass in just one number. So it automatically lets you know that it's a 5 by 5 matrix that you're creating. So you put 20, it will be a 20 by 20 matrix. So it must be an odd number, so we can't use 20. We have to use, let's say, 19 or 21 to want that number. So let's just do 5 first, and let's see how the medium blur frame will look like. So median blur, so it's grayscale in the scaled blur frame that we used earlier. So let's update these values over here, and let's go. So this is median blur, this is the blur frame. So it's just different kind of effects you want. So median blur will give, will take the 5 by 5 matrix, and you have different weighted averages based on the center pixel with respect to the pixels around it. Alright, so besides these, we can just close it, and we have some other filters we can use, such as the Gaussian blur. Passing the frame again, and then we pass in another argument, which is the size of the matrix. Right, now we look at our last filter that we want to share today, which is the bilateral filter. Bilateral blur. So far we have explained that the main goal of all these filtering is to smoothen the images and remove background noise. So bilateral blur does both. So it reduces the noise in the background as well as blurs the image. So what is noise in the background? It will include maybe some green, salt and pepper grains in the background. So if you've seen some images which have small dots of like black dots or white dots flickering in the background, this blur filter is able to remove them completely. Right, so let's move on and put filter. And then we are passing 4 arguments for this. First is the frame, followed by next variable, which is the diameter of each pixel neighborhood. So it just means like what's the kernel size in weight. And then next we pass in another variable called the standard deviation in the color space. So we just leave it as 75. And the next one is the standard deviation in the coordinate space, which is sigma space. So we'll just leave it at 75 too. These are just values that we keep constant. And this will be the bilateral blur. So that's the 4th one for this session. So these are the 4 blurs that are mainly used in image processing, and to really give a smoother image before we use things like the Kenny image pixel detector or half-line transform in future. So these are the 4 standard blurs that we will be sharing today, and let's put them all into one frame and see how's the outcome. Alright, so we are done with compiling all the frames into one, and let's take a look at the outcome. So let's see how the different frames will look like. Alright, so these are the 4 different frames that we had. So let's just make it a little smaller. Right, so in this picture here, we have the 4 different frames, and I'll just label them accordingly. So this will be the blur, the normal blur, it's the median blur, bilateral blur, Gaussian blur. Right, so let's apply it to the road video that we shared from the start. Okay, so now since we have done the 4 filters, we've compiled them. Let's take a look at how it looks like on the road clips file. You can see not much difference in the blur on the videos. But definitely we can increase the amount of blur that we have on them. So if we take them and put 25, on this, you'll see that the image is actually really blurred. You can see this. So if we are looking for maybe bright lights or certain road lines on the road or something, we can see that the road lines are very distinct. We can use a highly blurred filter whereas you can see that if we increase the kernel size, which is the number of rows and number of columns in the matrix. Right, so this you can see will come in really useful later in the discussion when we talk about half-line transforms and just trying to find out very distinct features on the road, such as the lane lines over here. So we don't want an image which has too many little details behind that might like confuse the program when we look at very distinct lines later when we do image processing. So blurring of the images are really the first step to doing the whole chain of different steps in image processing. So this is that, and next time we'll be looking at the more intricate functions of OpenCV that allow us to detect, recognize, and react accordingly to different features on the road. Right, so that's all for today, and see you next time.